everyone. So as Divya mentioned, I'm Vicki Murley, and this is Know Your Platform, Desktop versus Mobile. So who here in the room has had the experience of working on a desktop site, and then you go and view it on a mobile device or interact with it on a mobile device, and something unexpected happens? Raise your hands. Quite a few people in the audience have had this experience. Well, that's what I'm here to talk about. Mobile devices and browsers on mobile devices differ from the desktop experience. So I'm going to cover three main areas. First, I'm going to talk about fundamental differences between desktop and mobile browsers. After that, I'm going to talk about how to optimize for mobile displays and get into some very specific information. And finally, I'm going to talk about how some platform differences can affect key technologies that you're going to be using in your mobile sites and mobile web apps. So before I begin, I just want to issue a quick caveat. Divya mentioned that I worked at Apple for a really long time. It was actually over 10 years. And I did a quick calculation before I got here, and I found that it was 2,685 days that I worked at Apple. And that's actually working days. Weekends and holidays are not included. So my experience since then has been 15 days. And I actually spent a little and goofing for like 10 days. And I'm just pointing that out because most of the examples that I'm going to cover today are going to be illustrated in Safari, because that's obviously where the majority of my experience lies. But I don't think that's going to be too big of a problem because I see lots of iPads and iPhones in the audience. Okay. So let's get started understanding fundamental differences between desktop and mobile browsers. Okay, so a typical web page will look like this when viewed in your desktop browser. So how does a mobile browser take this desktop, this page that's intended for a desktop machine and a desktop browser, and put it onto a mobile display? Well, what happens is a width of 980 pixels is assumed, and then that content is scaled down to the width of the device. So in the case of an iPhone, that would be 320 pixels. So now we have a 980 pixel page scaled down to 320 pixels, and that's giving us a scale factor of 0.32653 approximately, 320 divided by 980. So on the desktop, the user interaction is different as well. If I want to see more of the page, I can use the scroll bar. I've highlighted it in green here so that you can see it even better. I can scroll up and down, or I can grab the corner of the window and resize. And what's actually happening here, there's a few things happening behind the scenes. First, there's the window of the application, and there's also this thing called the viewport. And when you are scrolling or resizing the window, you're actually behind the scenes resizing the window and resizing the viewport. So on a desktop browser, the window and the viewport are the same thing, and they're both resizable. On mobile, the story is a little bit different. We still have these two things, the window of the application and the viewport, but for a user to see more of the page, the interaction is completely different. So they may double tap to zoom in or pinch to zoom in. And when they do that, we still have this window that is a fixed size that we're sort of using to peer through and see the content of the page. And then when we double tap, the viewport dimensions are actually staying the same size, but the scale is changing. And then, of course, the user can, pan left or right to see more of the page. So on the desktop, the window and viewport have a changeable size, changeable by the user. And on a mobile device, the viewport is a fixed size, and the scale of the viewport changes. So why is this important to you, web developers? Well, this is really a fundamental piece of knowledge about how mobile browsers operate. And you can control the size of the viewport with a meta tag. And this allows you to tell the browser exactly how much space is needed to lay out your content. So here is an example meta tag for the viewport. It's meta name equals viewport, and content, and here I'm setting the width equal to 400 pixels. So I'm telling the browser that I'm going to need 400 pixels across to lay out my page. This is great. If you ever have a page that's intended for the desktop and maybe you have some white space down on the right-hand margin, you can set a viewport tag to really maximize your screen real estate and fill the entire page without having to go through the slightly more intensive process of defining custom CSS for a mobile page. And of course, this lets you really achieve perfect layout for your web apps, something that is, for a specific purpose, looks more like an app. You want that layout to be exactly as you intend it. So this kind of eliminates the guesswork. And of course, as we saw earlier, the viewport also scales on mobile devices, so you can customize that scaling behavior in this viewport meta tag. So width is one of our viewport tag settings, and let's take a look at the rest of them, and also take a look at their default and minimum and maximum possible values. So width has a default of 980, the minimum is 200, and the maximum is 10,000. Height is a calculated height. So if you're setting the width to any value, the height, if it's not set, is going to be calculated for you. And the minimum height is 223, and the maximum is 10,000, pretty tall. Here are those scaling settings that I mentioned. You can set the initial scale, the minimum scale, and the maximum scale. I mentioned on one of the first slides that if a width of 980 pixels is assumed, then the initial scale is calculated to be about 0.3. So that's what it means here when it says the default value of initial scale is calculated. You can also set a minimum or maximum scale to control how far a user can zoom in or out, and those values by default are 0.25 and 5 respectively. Finally, there's one more setting which you can use to turn off scaling altogether, and that's user scalable. The default value is yes, and the other possible value is no, obviously. Another thing that you need to know about the viewport is that there's this thing called the device width content. And what the device width content does is it is a constant that maps the viewport width to the actual width of the device. So device width on an iPhone would map to 320 pixels, and device width on an iPad would map to 768 pixels. I think device width is really handy when you want to have that kind of one-to-one ratio between your CSS pixels and what you're seeing on screen. So it's especially useful for web apps. When you're using this, don't forget to set the body margin to 0 pixels. Otherwise, you'll be getting that 8-pixel margin that's there by default in the user agent style sheet. And that's going to cause you to have a little bit of extra space, wider than 320 pixels, for example. And you're going to get this slight horizontal bounce back and forth and see a scroll bar at the bottom of the page. So far we've been looking at viewport tags that just have one parameter. Width is the one that we've been looking at the most. But of course you can chain them together. So here's an example of the viewport where the width, height, and scalability are all set. As you may have noticed from the table that we looked at, any values that aren't set explicitly will either use the default values or they'll be calculated for you. So for example, if you just set a width, then the height and initial scale will be calculated for you. And that's usually pretty handy. I see a lot of really crazy viewport tags out there, and that's one reason why I keep talking about it. So here's an example of a real-world viewport tag. Width equals device width, looking good. Then we have initial scale equals 1.0. That's already the initial scale when you have set device width. Then we have minimum scale equals 1, maximum scale equals 1, and user scalable equals no. I get it. You don't want the page to scale. It's understood. This sort of thing will work, but it's probably going to be confusing to the next person who looks at your code. So just try to use your knowledge of how the viewport works and do something simple, like set just device width and user scalable equals no for that particular example. Okay, so that kind of covers how content that's intended for the desktop is translated to a mobile display. What about the content that's actually on screen and when you or your users are interacting with that content? Well, as you know, on a touch device, there's no mouse, so there's no continuous input that you can get from hovering over things with a cursor. And there's no keyboard that's constantly available. All that you have available to you is this disembodied hand that's floating there. That's actually your hand, not a disembodied hand. But the way of interacting with mobile content on a touch display, there's a few things that have been built in to facilitate a better experience with touch. So one example is that if you tap a link, there is this link tap highlight color that shows up for a split second before the user's taken to the linked page. There is the copy or define selection dialog. So if you tap and hold on a piece of text, this is going to pop up after a few seconds. You know, there's no keyboard for me to use to select a context menu, so there has to be a way for this sort of thing to appear. And finally, there's the image open, save, or copy panel. So if I wanted to maybe save this image of this iPad mini, I could tap and hold on it, and then this panel would slide up and give me a bunch of choices for what I can do with that image. So these are all built-in behaviors that were created, because we're just interacting with these devices with touch, no mouse and no keyboard. They're really great for web pages, but they might not be appropriate if you are creating a web app, something that you want to, look and feel like an app, or if you even just have a control in your web page that looks like kind of an app-like control. So imagine you slave over this really beautiful looking delete button. It's got this great gradient, subtle shadow. The border on the bottom is like just perfect. I actually made this and I spent, a good amount of time getting it exactly right. And then the user taps and holds on it and this dialog pops up. Like obviously that's really disrupting the experience. It's saying, if I'm making a web app and I want this to behave like a real button, I don't want to give it away that it's actually just text behind the scene. I want the user to think that it's a button. So there are these default built-in behaviors and there are also ways to disable them. So the first thing, that gray highlight color that shows up around the link, that's often also really distracting if you're trying to create an app-like experience. And you can turn that off by setting the tap highlight color to transparent. You can also set it to other colors if it works for your design, but to turn it off completely, just set it to transparent. To turn off the copy or define selection dialog, user select equals none. And to turn off that panel that pops up, if a user touches and holds on an image, you can specify touch callout equals none. There are a few other implications of the fact that users are going to be navigating your content with a finger instead of a mouse. There's no hover, and in general, there's kind of a 1-to-1 tap-to-paint ratio, so things that you would hover over, let's say there's a string of menu items, you hover over one on the desktop and a submenu appears. On a touch device, that's going to require a tap for that submenu to appear, so it's kind of a 1-to-1 tap-to-paint ratio happening. Also, when something is tapped and there are mouse events associated with it, there's a 400 millisecond delay before those events execute because the browser needs to check whether a gesture is being performed. Maybe you're trying to scroll the page and not click a link or, mouse over a menu. So there's a slight delay as well. And speaking of mouse events, these are really, on a touch device, mouse events have to continue to fire, otherwise the entire internet wouldn't work and no one would be browsing the web on mobile devices, but they truly are being executed in sort of an emulated environment. So, you may touch an element on the page and a click event fires, a mouse down event, hover is triggered. Since this is an emulated environment, the order that those events are firing is never really guaranteed. So while most websites that have mouse events will work okay on a mobile device, if you really want fine-grained control, there needs to be a specific API for touch events. I'm not going to go into this in too much detail here. I really wanted to talk more about why an API like this is needed. But some of the available events are touch start, touch end, and touch move. You can also keep track of how many fingers are on the screen, which is something that you wouldn't be able to do with mouse events very easily. You can also create these sophisticated gestures in web page, especially when you use this in conjunction with prevent default. If you think about it, if I wanted to touch an element on the page and then have it track underneath my finger as I move it around the page, I would have to prevent the default behavior, which is the page pans when I touch and move. So when you use touch events in conjunction with prevent default, you can create some really sophisticated interactions like pinching to zoom, rotating, swipe, etc. on the content within your web pages. So like I said, I'm not going to go into this API in too much detail. There's also going to be a talk later at the conference on the pointer events API, which is an emerging standard to deal with touch events. But I just wanted you to kind of think about why we need this API on a mobile device. Okay, so those are some of the fundamental differences between desktop and mobile browsers. Now I want to talk about optimizing content for mobile displays. So media queries are probably something that you're all familiar with. This is a very common media query that harkens back to the very first days of media queries. We've all seen a query that, for instance, specifies specific CSS for screen versus print. Maybe you don't want the background images to be printed from your web page. So this is a very common example. And some useful media queries for mobile devices, there's device width, which allows us to detect smaller screens. So I can detect an iPhone by querying for device width equals 320, and an iPad by checking device width equals 768. Device width also has min and max variants that you can use as well. So this is very handy for detecting a specific screen size. Another media query type that's very useful for mobile devices is orientation. So I hear a lot of people listening for this orientation change event on the body if they want to show something. Let's say you want to show, you have a game on your web page and you want to show the game when the user is in landscape orientation, and you want to show the settings for the game when the device is in portrait orientation. Well, a complicated way to do this would be to listen for the orientation change event on the body and then go through the DOM and change a bunch of stuff, etc. A much simpler way is to just use the orientation media type with the portrait and landscape functions. And these will just automatically change your CSS once the orientation change is complete. So if you're rotating from portrait to landscape, in this example, my settings, the div that controls or houses my settings is going to be hidden. So this is an incredibly useful media type for mobile devices. Finally, lots of our mobile devices, and even now our desktop devices, are getting super high resolution displays. And unfortunately, I just got this Retina MacBook Pro recently, and there was something about looking at web pages on this as opposed to my Retina display iPad. It was just so much more obvious that a lot of websites need to be updated for these high-res displays. So one way you can do that is to use the device pixel ratio media type. And on a Retina display for iPhone, iPad, iPad mini, or not iPad mini, iPhone, iPad, and this MacBook Pro, you can query the device pixel ratio. On a non-Retina display, it's 1. On a Retina display, it's going to be 2. And other high-resolution displays have other device pixel ratios, so you can check those as well. In this example, what we're going to do to provide a really sharp image to the high-res display, I have an image, and I've set the background size, and the size of my actual image is 400 pixels by 250 pixels. For my normal display, I'm just going to serve that image as my background image. For my high-res display, I'm going to have the same image that has the dimensions doubled, a high-res version of that image, and I'm going to put that into my 400 by 250 pixel area. So basically, we're going to be taking a larger high-res image and squishing it down into a space that's half the size so that it looks sharp on a Retina display. It's not always practical to use background images everywhere, though. So remember that you can also execute media queries in JavaScript. So if you wanted to set a high-res variant for an image tag, for instance, right now the way to do this would be to create a new image in JavaScript and then execute your media query in JavaScript. And you can do that by checking style media in window. And if that exists, then you know that you have that available. And then you can check window.stylemedia.matchmedia, and then inside your parameter to that function is your media query. So in this case, it's screen and WebKit min device pixel ratio equals 2. If that's true, I'm going to serve up my high-res image. If that's not true, I'm going to fall back to my standard image and then append that new image element that I created to the document. So here we're looking at one way of checking in JavaScript what kind of display we might be on. You can also query the device scale factor directly. So our add images function would look a little bit different if we use this. Here we would create our image in JavaScript. And here we're just checking the device pixel ratio property on the window. And if it's greater or equal to 2, again, we're going to serve up our high-res image, and if not, our low-res image. And then append that image element to the document. Finally, when you're thinking about making the display of your content super sharp on a mobile device that has a high-res display, remember that anything that's drawn by the browser is going to be sharp. And if you've looked at anything on a high-res display, this has probably been obvious to you. The text is always very sharp, whereas anything that is a static image like a PNG or JPEG that hasn't been optimized is going to look blurry. That's because that fixed image size is being stretched over a set of pixels that is twice as much as it actually has, so it's always going to look blurry. To get around this, you can try to use, CSS has come a really long way. So if you use built-in CSS to draw things like buttons, even things like logos, etc., any type of gradient, web fonts, you can make some really great logos out of all these interesting fonts out there. Anything that's drawn by the browser using these technologies is going to look sharp. And of course, SVG is always an option. A lot of people are using SVG to make things look sharp no matter how far you zoom in, and it's a technology whose time has come. Okay, so I have a few minutes left, and so lastly, I just want to go over a few points regarding how platform differences can affect some of the key technologies that you're using on mobile devices. So sometimes on a mobile device, there is no exact equivalent to something that you're used to using on the desktop. So a great example on iOS is input type equals file. As of iOS 6, you can now capture from the camera either an image or a video, but there's no file system navigation. So you're not going to be able to see a dialog that pops up like you would see on the desktop that says open and lets you go navigate through everything and attach a file. So sometimes there are platform differences that crop up because there's no exact mobile equivalent, just because of how the mobile platform is defined. Sometimes the people who are creating the mobile platform decide to make a user-centric design choice. So one example of this is that on iOS, focusing a text field from a load event is disabled. That's because when you focus a text field, the whole page zooms in and the keyboard pops up. So that's not an experience that we wanted people to have, and so this is disabled by default. Another example is media playback can be different on mobile devices versus the desktop because of these same kind of user-centric design choices. So for example, autoplay and automatic buffering are disabled. If a browser on the desktop encounters a video tag, it will automatically start downloading and buffering that video. But you may not want that on your mobile device because you're using a lot of data to download that video, and maybe you're never even going to view it. Autoplay is disabled because maybe you never even wanted to view it. On iPhone, the video always plays full screen with the default controls overlaid. There's playback only from a single source. So something like the Media Controllers API, which allows you to control two pieces of media with a single controller, that obviously doesn't work on iOS. So sometimes there are some user-centric design choices that make these behaviors slightly different between the desktop and mobile. The last thing that I want to talk about regarding platform differences is performance. And I'm sure that you guys think about this a lot, but it's a point that just never gets old, so I want to drive it home one more time. Our mobile devices are so sophisticated these days. They're shiny, they're responsive. We forget that they don't have the processing power or memory capacity as our desktop devices. iOS, in fact, uses a system-wide memory management system. So it's not as if every web page, for instance, gets a certain amount of memory allocated to it. The memory is managed system-wide. So let's say you have 10 apps running, doing 100 different things. The memory that's available to the browser is going to go down. As that happens, and as memory becomes more and more scarce, applications that are in the background are quit automatically to free up memory, and eventually, if enough memory still can't be freed, the application that's in the foreground will also be quit automatically. So it's always important to think about your memory footprint on mobile devices and reduce it wherever possible. So a few things that you can do, you can always minify the JavaScript that you're using, or if possible, just hand code it. If you really only have like 1 or 2 animations or a few things that you're relying on that JavaScript library for, just write the code by hand and do away with the library. A lot of the time, JavaScript libraries are meant to obfuscate the differences between different browsers. Especially if you're writing content that's just for a single mobile device, you really may not need to use that JavaScript library. Another tip is to cut down on the total number of images that you're using. Even if you're using an image for a button, for example, even using CSS to draw that button instead will reduce your memory footprint. A decoded image uses probably more memory than you would think. So here's just a really short example. This image is using 53K on disk, but when it's decoded, the amount of memory that it's using is the height times the width times the bytes per pixel, which adds up to about 600K, and that's just for one image. So those are some platform differences that can affect the key technologies that you're using on mobile. And that covers all 3 points that I wanted to hit. In conclusion, I just want to say a few things. A lot of the time, the core technologies like HTML, CSS, and JavaScript are often the same on desktop and mobile. But variations can crop up due to differences in hardware, the interaction model, and design decisions. Knowledge is power. The more you become aware of these differences, the smoother your development is going to go. So hopefully this presentation today is going to help you in the future. And finally, always consider performance when you are developing for mobile devices, obviously. So with that, I think we have about a few minutes left for Q&A. Thank you. Hello.
Hi. I have a question about the DOM on mobile Safari. So when you scroll with mobile Safari, the DOM essentially freezes, and it's kind of frustrating if you're trying to do like something like a nav that follows you or parallaxy type stuff. It's kind of impossible to do. Do you know if that's just sort of the hand we're dealt with mobile Safari, or is that just a performance reason, and as like RAM gets, we can put more RAM on our iPhone, it'll get better, or what?
Well, I would say at the moment that's an implementation detail. I'm trying to think of this other example that I can't think of at the moment that illustrates this very well. But what you're saying is true. There is a performance consideration there, and it is intentional. Whether or not it changes in the future, I can't really say. I wouldn't be able to say. Maybe there's something that you could do that would solve your problem that would be slightly different. So maybe we could chat after this as well.
Yeah, I mean, essentially the way to get around it now is you do the scrolling on your own. You kind of rebuild the scrolling behavior with JavaScript, and it's super hacky.
Oh. So are you saying that you want to have native style scrolling inside of an element?
Well, really, I mean, what this ends up coming down to is like we want like a fixed nav at the top of our, of our mobile sites.
Okay. So there's actually a new CSS property that was added, I think in iOS 5. I'd have to look it up to remember the exact name of it. But it actually will enable the native style scrolling inside of an overflow div, for example. So,
overflow touch is what you're talking about, right?
Exactly.
Okay.
So have you tried that?
Yeah, the performance isn't, it's not the same as native still. So, which is, I mean, maybe it's just really a design thing where designers are trying to make us make, native style apps and really just on the web, there's different considerations, different limitations?
I think there shouldn't be a big delta in the performance because they're both using the same mechanism under the hood. It could be that there's something on the page that is painting a lot or causing the performance to degrade.
Oh, so it's my fault.
No, it's not your fault. But that might be something to take a closer look at. Like, you know, for instance, if the whole thing is repainting every time it tries to move a pixel, then it won't perform as well. That's the only thing I can think of as to why the performance wouldn't be the same, because it's definitely not intentional that they're not the same.
Okay, thanks.
So I'd be happy to look at it in a bit if you want. Hello.
Hi there. I'm slightly worried by the premise here, which is there's mobile and desktop, whereas actually we now have a large continuum of things in between. I know you come from Apple, so your examples are very Apple-focused, but there aren't.
I only have 10 days of non-Apple experience.
There aren't just things this big and things, you know, desktops, and you know, the iPad and the iPhone are not the only screen size and shapes in the world anymore.
Right. What I should have said in the beginning is that most of my experience is from Apple, but hopefully you can apply these concepts to other, you know, mobile devices, non-Apple mobile devices as well. I mean, several of them, media queries are a standard thing that, you know, all mobile browsers should support on all devices.
Right. No, it's more the sense that we can query how, you know, pixel density for display. What we can't easily query is how fat is your finger on that screen at that point to decide how big to make the buttons. That's the piece that's kind of awkward. Chrome on Android, actually, if you click something ambiguously, will then zoom in and say, which one of those were you trying to click? Which is a kludge around this. If you're designing for iOS, you have only 4 form factors now. It was only 2. The iPad mini is making this obvious to the iOS designers too, which is Steve Jobs' comment about filing down your fingers ends up being true on that, because the stuff you made for iPad is now half the size and you can't quite hit it. So I suspect we're going to need some more subtle media queries to say, what is the actual likely resolution of being able to click here? And we haven't quite got that with the touch APIs yet.
I'm not sure if I think that, I'm not sure if I think that that's 100% true. I mean, I think that I'm not a designer, but I know a lot of people who are, and there's also, I know that there's something called the Human Interface Guidelines, and that specifies that, you know, a button should be 40 pixels tall on a touch device. So I'm not sure if, you know, actually, I think it's more a matter of knowing when something is going to actually be 40 pixels tall. Like you mentioned, I have this button on the phone and it looks smaller on an iPad. I think some of that comes down to understanding how the scaling works and knowing when you have a one-to-one mapping of the CSS pixels to the actual screen size and when something is scaled down. So I think you have an interesting argument. I'm not sure exactly what the resolution will be.
Yeah. CSS pixels sort of have an assumed viewing distance built in. So in effect, what those ratios are saying is how far away from your eye you should hold the screen. But that's independent of how big your finger is when you're trying to touch it. So I say there's another parameter we're not measuring well. Anyway, sorry. Something that struck me.
Sure. Do we have time?
Yeah.
Okay.
I'll be quick. I can actually answer that question that the Gus guy did.
Great.
I'm Tab Atkins, CSS Working Group member.
Oh, hello.
The Media Queries 4 spec, which is being written right now, adds 2 new media queries specifically for handling uncertainty around touching and whatnot that tablets versus desktops versus whatever gives you. You have the pointer media query, which goes fine or coarse, which is for like exact pointing like a mouse can give, or approximate pointing like a finger does. And then the hover media query tells you whether or not you can hover something, so you can design your API around that. Additionally, in the values and units spec, we're going to add a touch unit, which is just one touch is as tall as a touch target should be on that platform, which is whatever is appropriate for there. So you can at least say button, min height, one touch, or something like that.
Interesting. Thank you. A glimpse into the future. Yes.
So I was wondering, you said, you know, obviously switching out image elements whenever possible, and definitely get really fascinated with that, trying to replicate as much as I can with CSS or SVG. Do you know, is there on like even just specifically iOS devices sort of a tipping point where you're pushing too much processing, in terms of shadows and text indents and?
There are definitely things that, like a canvas, for example, creates a backing store, and so does an image. So in that case, if they were the same size, you'd be using the same amount of memory. And there are also things that, cause more repainting than a simple element would, like a simple solid element. But I think a lot of those things are kind of, the solution is to kind of learn more about the tools and how to make sure that your drawing is optimized. I think there's going to be a talk, it's either later today or tomorrow, that's all about, it's today. Oh no, performance. Aria's talk? I know there's going to be another talk that's not performance. And I believe one of the things that the person giving that talk is going to cover is just about using the tools to look at repaints. So the answer to your question is yes and no. And I think the best solution is to use the tools that are available to see what's actually happening.
Thank you.
Sure. Okay, that's it for questions. It's time for a break, I think.
Thank you, Vicki, so much.